This meeting is being recorded.
Okay, now it's working. So let me share my screen once again while people are still joining. Hopefully you're able to see my screen. So today the topic of this fourth NERO Network Café is basically on a continuous series of webinars on extreme fire behavior. And today we'll focus on the dynamics of international operational response. We have two talks from Héctor Alfaro Fernández from the Emergency Response Coordination Center from the European Civil Protection Mechanism based in Spain, Hector. And we also have Jean-Baptiste Filippi from the National Center for Scientific Research from France. One talk basically it's from the side of the practitioners, focusing on the needs and how things work on the field, and basically on the preparation stage and response stage. And from the Jean-Baptiste Filippi, we'll get an overview of the research perspective on the modeling of fires. So first of all, a few words about the NERO network, since for someone might be the first time that you hear about NERO, and we might have newcomers in the conversation. So NERO is a cost action, is a network focusing on investigating the extreme fire behavior development. And of course, the aim of NERO project is to bridge the gap between the research community and the practitioner side. If you're looking for more information about the objectives and of course the ultimate vision of NERO, you can visit the website of NERO project on nero-network.eu. And also another brief overview of the participating countries at this moment. Until a few days ago, we have 32 countries join NERO network, and with more than 155 participants, with 21% of them being practitioners and 26% being women. Also, as you can see, we have many countries also across the globe joining, and of course Australia and United States from across the pond. So a few words about what NERO offers through this cost action. Basically, a great advantage is that you have access to funds for exchange visits, either in person or visual. And of course, you can also have funding for conference participation. Of course, all this work has to be connected with NERO activities and NERO objectives. And of course, also regarding conferences to communicate outcomes within the NERO network. Again, for more information, you can visit the NERO website in /grants, where you can find more information about how can you apply for this kind of grants. This kind of webinar series belongs to the working group 3 of NERO project that focuses on the capacity building. And this project basically has various objectives, focusing mainly on the exchange of knowledge and experience, improve technical skills, do this kind of bridge between the research community and the practitioners, and of course, create this kind of mentality of co-creation of tools from both sides, from the research community and of course the operation side. This kind of webinar series basically offer a chance for a dialogue between researchers and practitioners, and we have this kind of discussions on the applicability of novel research. Again, for more information, you can visit the website, also to watch the previous webinars. If you have more information, if you want to have more information or a few questions about the working group 3 activities or how it's engaged with other working groups within NERO, you can directly communicate the working group leaders, Fabio Silva and Nuria Prat, for more information in the emails below. Now, as I mentioned, and without any further waste of time, today we have two talks. One will be given first from Héctor Alfaro Fernández. As I mentioned earlier, he is from the Emergency Response Coordination Center of the European Civil Protection Mechanism. And then we'll have another talk from Jean-Baptiste Filippi from the National Center for Scientific Research. As far as I remember, the time allocation is 35 minutes, I think, for Hector's presentation, and then another 30 minutes for Jean-Baptiste. So hopefully at the end we'll have a very interactive discussion with your questions, and the floor will be yours to ask any questions to the presenters. Hector, the floor is yours. Let me stop sharing my screen.
Okay, I will start my screen.
And now you would be able to present.
Yeah. Now, can you see my screen in presentation mode?
Yeah.
Okay.
Thank you.
Thank you very much, Georgios, for the presentation, and also Fabio for inviting me to this webinar. First of all, I would like to clarify that I'm a firefighter from Spain, from Andalusia. I work for Infoca, but now I'm seconded national expert in the Emergency Response Coordination Center that is based in Brussels, in Belgium. Okay, so let's start. I will try to show you how the mechanisms work, how the ERCC is implied in operations, and how we use different tools for it. So the civil protection mechanisms, that I will refer to it as the mechanisms, that is easier, is the framework that regulates the DG ECO's civil protection activities. ECO is the European Civil Protection and Humanitarian Aid Operations, and the objectives of the mechanism is to strengthen the cooperation in the field of civil protection by improving prevention, preparedness, and response to disaster, to different types of disaster, not only wildfires. It was created in 2001 and is composed by 27 EU member states plus 10 participating states, as you can see in the slide. And this the mechanism is based in responsibility and solidarity. Okay. The Emergency Response Coordination Center is the operational head of the mechanism, let's say. Was set up to support, coordinate, and faster response to disaster inside and outside Europe. The scope is worldwide, and using resources from the countries that participate in the mechanisms, those 37 countries. The center, the ERCC, operates 24/7 and liaises directly with the national civil protection authorities of the country in need. It means that it's the country that activate the mechanism, and I will explain later how it works. The ERCC monitors disasters around the globe, maps disaster risks, provides real-time information, and coordinates joint European response operations. As you can see here, yesterday, the ERCC was monitoring, as an example, this tropical cyclone, Trami, that will impact, is impacting the Philippines. So it's just to show you how it works, an example. But how work the mechanisms? How is activated, and who can activate the mechanisms? When a disaster happens in the world, it doesn't have to be in Europe, the affected country can request assistance through the ERCC. Usually it's when they are overwhelmed because of this emergency. When they request this assistance, we say that the mechanism has been activated. Okay, then the ERCC share this information with all the member and participating states in the mechanisms, and those countries can offer assistance. Assistance that can be equipment, can be assets, can be expert, depending on the request. After that, the country that is asking for support needs to accept these offers. Sometimes we have many offers and they don't need so many, and sometimes it's the opposite. There are not so many offers. After that, when the offers are accepted, The ERCC coordinates the deployment and the delivery of the system. Also, the ERCC may deploy a team of EU civil protection experts to coordinate on the field the deployment. And after that, when everybody comes home, and we say that the activation finishes. Okay, and it works in the same way for all type of activation. Then we'll see that the wildfires is a little bit different because usually it's really fast. To have this capacity to be able to reply to this request, mechanism is organized in 3 layers. The first one is the spontaneous offers that are national capacities that countries, the mechanisms are offering when there is a request. The second layer are capacities, also national capacities, but that are included in the European Civil Protection Pool. That means that are capacities that are committed with the mechanisms. And we'll see later what implies that, because it implies standards, but also the financing is different. And the third layer is rescue, that is a safety net with some assets that I will explain later. So we have 3 layers of response. The second layer, that is the pool, was developed more than a decade ago, and countries can commit their national capacities for 1, 3, or 7 years. That means that they need to go through a process of certification and have its quality criteria. But there's financing to achieve this standard. So, and it's not only during the deployment, but to certify your teams, you can have some funding, so you can adapt your capacities to be part of the European Civil Protection Pool. Here you can see all the registered capacities that are in the pool, more than it's close to 100 registered, must offer capacities in different types of emergencies. You can see that there are capacities for floods, medical capacities, wildfires, CBRN, and some maritime incidents, and so on. The third layer that I told you before is rescue. This was established in 2019, but the origin of the rescue was 2017, after the big fires that happened in Portugal and many countries. So there was a lack of response because many countries were busy with their own emergencies. So here Commission started to think in create this layer that was put in place in 2019, and includes regarding wildfires, it's only aerial means, planes and helicopters. Here we have all the capacities that are in rescue in the third layer, and you can see that are for different type of emergencies. But we are going to explain now what's the financing difference between be part of one or be deployed with one or another layer. When there's an spontaneous offer, the mechanism, this means that you are deployed under the mechanism. Or it's not a bilateral deployment. When there's an spontaneous offer, the mechanisms cover 75% of the transport cost. If the capacity that is deployed is in the pool, meaning that it's certified, as we see before, the mechanism is covering or is financing the operational 75% of the operational cost plus the transport, 75% of the transport. If the capacity deployed is in rescue or aerial forest firefighting assets, inside Europe, the Commission financed 75% of the transport costs plus 100% of the operational cost. If the operation is outside Europe, it's 100% of everything, operational plus transport cost. So it's different. What's the difference between the being in the ECPP or being in rescue? Okay, it's not only financing difference. As you can see in this map, here we have all the capacities that are in the pool and in rescue. In the pool are in orange, and in yellow we have all the capacities for firefighting that are in rescue. The main difference is that when in capacities in rescue, in the ERCC, in the Emergency Response Coordination Center, we are tracking their availability because the Commission or the mechanism is paying for their availability. So we track it. It means that if we ask for deploy one plane, 2 planes, or whatever that are in rescue, if they are available, because we know it before, this will go. While if they are ECP pool, they are in the pool, they could be available or not. When we ask for it, the host country will say, okay, yes, it's available or not. But we don't know in the ERCC beforehand. So it's very important. But when there's an activation, first we go for the first layer, meaning that we put in the CESI, that is the Common Emergency Communication and Information System that all the mechanisms, all the countries in the mechanism have. So the request is put there. Then we go for this spontaneous offer. If there are no spontaneous offer, or meanwhile, we go for ECPP, depending on what the country that is requesting was requesting. For instance, if imagine that, can you see my mouse? So imagine that there's a fire in Italy, and Italy is requesting heavy aerial means. So different countries can do a spontaneous offer that we don't know which are those now until they put in the system, because those are national capacities, but then at the same time, we start mobilizing ECPP. They are asking for, imagine Canada, we should start with ECPP from France or Greece. If Greece or France say, okay, we cannot go because our assets that are working or are involved in national operations, then we go through rescue. And in rescue, we know which planes or which helicopters or which modules are available. Okay, so, and we legally, we should go always through this ECPP before go to rescue. But there is a point where if operationally is more operational, go to rescue directly, as we did with the fires in Madeira. Didn't make any sense to mobilize ECPP from France or Greece from the beginning, when we had the planes from Spain in rescue that were deployed in Malaga, that is closer. So this is the way we work in the ERCC with the mechanisms. Okay. Also, since last year, there's a program that is called pre-positioning of ground forest firefighting teams with or without vehicles. And it means that firefighters from countries that usually are not used to have wildfires are deployed during the summer, are pre-positioned during the summer in countries like in this year was Greece, Spain, France, and Portugal. So they can share experience, they can learn how to work in different type of environment, different type of wildfires, and also exchange knowledge. And if they are needed, they also can support in the country when there's a fire, as it happened in Greece this year or last year. Let's see an overview of the activation. As I said before, the mechanism is not covering only wildfires, it's all types of emergencies or disasters, like the natural hazard, of course, wildfire, but also floods, earthquakes, cyclones, human-induced disaster, like wars. Now, one of the attacks we have every day in the ERCCs, the Ukrainian war, but also health emergency like COVID in the last years, or consular assistance. Since it was created, the mechanism has been activated around 760 times for all types of emergencies, and here we can see since 2002 the number of requests and pre-alerts that in the mechanisms. As you can see, 2020 was a big change in the trend, and it was because of COVID. And then another change was in 2022, that is Ukrainian war, that you can see that there were more requests only for Ukraine, but for the rest of the world. As I said at the beginning, the mechanisms is response to all type of disaster, not only in Europe. And if we see here natural disaster, we can see that it's all over the world. But in red, you have wildfires, and most of the activation for wildfires are in Europe. But we also have different activation outside Europe, and this year and last year, especially in South America. And if we analyze those years from 2002, we analyze the type, which type of disaster, natural disaster, had request assistance. We can see that more than half of them where the request was for wildfires, and second one was floods with 30%. So we can see that it's one of the main goals in the ERCCs to be able to respond to wildfires. And if specifically, we can see here all the activations just for wildfires in 2007. And we can see, as I told you before, that in 2017 was the year with more activation. That was when Portugal had those big wildfire or extreme events. And it was this was the point that triggered the creation of the rescue layer. And so far, 2024 is the second year together with 2007 with more activations. As you can see here, in 2024, most of the activations were for deploy aerial means. As you can see, it's more than in total 65 between planes and helicopters, and the activation were more than in Europe, but we also had Bolivia and Guatemala in the Americas. This the assets that were deployed during the activations in Europe, and as I told you before, most of the activation were only for aerial means. The only activation that were requesting ground forces were the two activations in Greece, where 8 teams were deployed in the first one. And in the first activation, ground forest firefighting teams with vehicles from different countries. Bolivia and Guatemala were around 14% of the GFF, of the firefighters that were deployed this year, were as obvious reason to Bolivia and Guatemala, because when we have requests from Americas, is normal. We deploy usually firefighters, or in this case also the Forest Fire Advisory and Assessment team from Spain. If we compare the activation that we had this year with last year there were less activation, but were deployed more first responders, more firefighters, and less helicopters. It was because there were activation in Bolivia, Canada, and Chile, where many firefighters, close to 400, 450, were deployed to those countries to fight fires. And as you can see in the timeline, the season last year, we have seen that it's happening all the time. We cannot say we have a forest fire season. When you can you can have requests from worldwide. We know that we have different fire season in the North Hemisphere, in the South, in the equatorial zones, but also in Europe, the fire season is each year longer, start before than ever and finish later. Now I'm going to go through the work we do in the ERCC, how we try to monitor how is the wildfire situation, especially in Europe, but also around the world, because we need to have a situational awareness of what's going on, and we need to support the decision making with information, and it also can allow us to be able to preposition assets, or to be able to make decision in advance to know where we can have problem and what assets that in those that I showed you in the map before we should deploy depending on how is the situation in the general, the big picture in Europe. Okay. On this purpose, during the summer, the ERCC is reinforced with a wildfire support team from mid-June until mid-September, with national experts and scientific experts, and duty officers, and one second national expert, that is me. So daily we have 2 national experts, 1 scientific from the Aristotle Consortium plus me, working in this cell. Okay. For doing that, we use different tools, and for monitoring, we use what Copernicus can offer us. We see that from the Copernicus Emergency Management Service, we use not only rapid mapping, but also EFIS or GWIS. But we also have the Aristotle service, that is a consortium that provides scientific expert advice to the ERCC, and it covers different types of disaster like severe weather, floods, earthquakes, tsunamis, volcanoes, and wildfires at the global level. We also have in ECHO, we have an analytical team that is located in the ERCC that can provide with maps and support our cell. And this is an example of one of the information that they were preparing for the last year wildfires. And this one is from this year in Bolivia, from the deployment to Bolivia that finished 10 days ago. So what type of tools are we using? Okay, mainly we use the European Forest Fires Information System for Europe, and the Global Wildfire Information System for the rest of the world. The main tools that we are using to have situational awareness of what's going on. And from EFIS, what we use the current situation viewer, where we can check how is the fire weather index, and we can highlight those areas that are in high or have the higher danger. We also work with the statistics portal to check the trends, and then after the season to analyze how was the season. And we also work with the long-term fire weather forecasts. The same with the same in GWIS. It's important here to understand that when you are using, or we are using a statistic from EFIS, in the statistics, they are showing the number of fires or burn areas of the fires that are above 30 hectares, meaning that if we check, for instance, the trend of number of fires in Spain above those, above 30 hectares, the trend is that is increasing, but the number of ignition in Spain during the last 10 years were decreasing and now are more or less stabilized. So we need to be aware. We also work with information of the countries, especially the fire-prone countries in Europe, using their tools like the National Fire Danger, and we compare with what we have in EFIS, and some of these maps are available online, and some of them the countries are sending to us. But moreover, we have a weekly meeting with all the countries in the mechanisms, where the fire-prone countries show to the rest of the countries how is the situation, what's the forecast, so all the countries can have the big picture of what's going on in Europe. It's situational awareness. And what are we doing with all this information? Okay. We have a daily briefing, internal daily briefing in the unit with this wildfire support team, and during this briefing, we try to analyze the situation in Europe, and like you can see here, we try to highlight what's going on, which areas will have more or less problems, and when we are working with the fire weather index, it's very important to know that it's wildfire danger. Okay, it's danger. It's not risk. So it's the probability of wildfire occurring, or happening, but it doesn't take it into account its potential impact on assets, buildings, facilities, or people. Okay, we also, as has to be, when you are working with wildfire, you need to know you need to forecast the weather. So we also try to do it to go deeper in the info that the fire weather index is giving to us. We forecast relative humidity and wind speed. So as you can see, we work with a lot of different tools. So here we have the rain accumulation. Okay, and then we try to analyze in those spots that we identified previously how is going to evolve the situation. In this case, the fire weather index we select a couple of points in this case, North Lisbon, North Andalusia. As you can imagine, we cannot go deeper in each point in each country, but we try to understand what's happening in the whole continent. So it's the reason we cannot go deeper. That will be perfect. But this is something that each country needs to do, and I hope, or I know that most of them or some of them are doing it. So we analyze different parameters, meteorological parameters in those spots. And for instance, here it was in Perpignan. Okay, checking how is the fire weather index, how it's going to be in the coming days, when it's going to decrease the danger and all this info. And in this case, there was a wildfire in Perpignan, but the France didn't have to request assistance because it was like 400 hectares, so they didn't need support from the mechanisms, hopefully. And for situational awareness, also in the ERCC, with this wildfire support team, we deliver a weekly bulletin with info from all the countries, all the 5 prone countries in Europe. We use all the tools I showed you before. We use the information that the countries send us. We use the information we have in the weekly meeting we have with the countries, and with all this info, we prepare a bulletin showing what has happened in the last week and what can we expect for next weeks. Okay, this just it was for situational awareness, is to monitor the situation. Now, what do we do when there's an activation, when there are active wildfires? Okay, we continue working with EFIS, GWIS, but or Copernicus, and with all those tools, we try to monitor the wildfire, to see what's going on, what's happening, and check the situation. But we also use different tools like local webs. We look for info in Twitter. We ask to the member states that are having fires to report to us how is the situation. And of course, we use meteorological page like the ECMWF, European Center for Medium Range Weather Forecast, Weather Central, Meteorologist, Windy, WX charts, NOAA. So we try to use all the tools we can. And also the Copernicus browser to have satellite imagery. Okay, as you know, Copernicus mapping service can provide with rapid mapping when it's activated, and for doing that they use satellite imagery, but also spatial data. Who can activate Copernicus? It can be activated for the country that has the emergency. It can be activated also for international organizations or for the ERCC. So when there's a fire that we would like to monitor, we think that is important to check it, we activate Copernicus directly from the ERCC. So Copernicus can provide us with rapid mapping. Copernicus has another service that is risk and recovery, that is after the emergency. When the emergency finishes, it can be activated, but it has another purpose. Okay, we also use films. Of course, it has a lower spatial resolution, but it has a higher temporary resolution. So it can provide us with info that we need when we want to know if the fire is still active or not, or with the flanks or what part of the fire are active. This year, we start developing this tool. It's based in ArcGIS, quick capture, field maps, and it's a tool that, for instance, Portugal and some regions in Spain use. That is used to have a real-time info when the modules are deployed. We start testing it in Portugal this year with pre-positioning teams, and let's see if we can develop it. But you can integrate a lot of info, national info, info from the ERCC, everything in this type of tool that I think are really, really useful. We also have info from the fire with the reports that the affected country is sending to the ERCC daily, plus the daily reports of the deployed teams on the field. We also can deploy a liaison officers or a UCP team if it's necessary, and we have daily meetings, BTCs with them, and they also report to the ERCC. So it's the way to communicate and see what's going on. And after the operation, we have a hot wash with the teams, not always, but usually when we deploy UCP team or we deploy fast teams, we have a hot wash and also with the liaison officers. Meeting with them, and in general, at the end of the year, usually there is a lesson learned where all the countries go together and talk about how was the fire season this year. And for instance, this year will be the first week of December in Madrid, in Spain. Last year was in Rome, so 3 days. Okay. So with all those tools, what are we doing? Okay, we use the tools to see how is the situation, where we have active fires, and then when we have activations, we try to go deeper there to try to understand, okay, these fires start here, when are they going to have the opportunity, the deployment will last until this day or this other. I mean, we use the information we have, the tools we have, to try to go before the emergency, to prepare, to be ready if we are going to have probably it is going to be needed more support or not, or the opposite. Some examples of what we do during those activations. This one is in North Macedonia. You can see here the hotspots were 2 fires, and here you can see that we were highlighting that there was going to be a wind change, so it wasn't going to be a problem because most of the fire, the flank that was going to become the head was going to agricultural areas. So, and there were no populated areas close. So it's the things that we are trying to do. In this case, it's in Bulgaria this summer. So we were monitoring it and seeing that during the night there was the fire, the speed of the fire was lower. There was no wind there. So and the fire was stopping in the roads and croplands. In this case, in Bulgaria, we had Copernicus activate, so we had maps from Copernicus, and okay, we were also using the Copernicus browser to check with image how was the situation, and we were seeing that the fire was stopping in greenest forests that were limiting the fire spread. And on the opposite, the open forests on grassland were active, were spreading fast the fire, and with the anomaly and checking all the index, we were seeing that which day the conditions were going to change. But we also complement this checking the different weather page. Here's another example in Turkey that was a fire that burned everything in a couple of hours, and 2 people died. And this is another example, in this case in Albania, with the information that Copernicus provides. All the information from Copernicus is public, and if you go the rapid mapping service, if you go to the web, you can see everything, and you have a situational report where you can have an overview of the emergency from the first day until the last day, with all the maps, with everything, and also when it's going to be delivered the next map when the emergency is still active. And we also use those statistics to try to understand what was happening during this summer. As you could see that checking the statistics that all in the eastern countries where we were having most of the activations, they were breaking records in terms of fire activity, but also in burn areas, while in the western countries was the opposite, until we have Portugal that, 3 days, we were in Europe using those EFIS statistics. The European Union was below the ban area of the last 16 years. But after this week in Portugal, we were again over or above this average. Here is an example of what Copernicus can provide, and you have, if you want more info about how we work, what we do in the ERCC, you can press this link and you have a story map with all the season, how everything is organized, and information of all the deployments. And here you have some useful resource. And to finish, I would like to highlight that it's important. I work for I'm working for the ERCC, that we are focusing response, but it's important to say that for me, prevention in wildfire prevention is key. But we cannot forget response, because when we have a wildfire, we need to be able to give a response. But in medium and long term, prevention is key, and the more successful the prevention be, the smaller will be the budget we will need in the future for response. And I think that another very important thing that the science and the practitioner should make people understand is that there are some extreme wildfires events that we cannot fight to them. Nobody's expecting, or we don't have capacity to fight them until the conditions change, like the weather, the landscape. So nobody's expecting the first responder or the army to stop a tsunami. Nobody's expecting that. So, but unlike those extreme wildfires, we can prevent them. We cannot prevent a tsunami, but I think we can, and we should prevent this type of wildfires. And just to finish, science, knowledge, and technology are key in this process, and we will always need somebody on the ground with a hand tool putting out the fire, but I cannot understand fighting a fire without analysis and with all the support of the science. So meaning that we can go in advance and anticipate what's going to happen. So, and that's it, and thank you very much.
That's great, Hector. Thank you very much for this excellent overview of the ERCC activities and basically how you integrate all these tools for monitoring response and dealing with the situations and all these emergencies, especially focusing on wildfires. I think there are so many questions that we will have to address after Jean-Baptiste's talk, so please be patient until then. And we can move on with the next talk of the day from Jean-Baptiste Filippi. He'll give us an overview of coupled fire atmosphere models based on the work that he has done in the past with simulating past wildfires with Forefire, Meso-NH developed in France, and also the integration of SATS tools into real-time fire predictions and, of course, wildfire management. So, Jean-Baptiste, the floor is yours.
Yeah, thank you, George, and hello to everyone. So I'll try to be as quick as maybe I can. So just to, and thanks Hector for the overview. And as Hector showed, there are new kind of fire, and we are making new kind of tools based on physics and science with the aim of delivering some results that are going to be meaningful as well. So here's the plan. First, I do some physics just to see how the problem is seen by scientists maybe, and what's the model, how they work, some codes, the coupled model, which is a specific subject and probably the future of the decision-making tools, and how to deliver that to the field. So that's our problem. It's a fire propagating, and it's basically all about energy. So that's an experimental platform we have down in Corsica. And just to show you how we measure the stuff at the flame scale. And based on that, so it's just 15 kilogram of fuel. And this is how we kind of, with the image and the sensors, we get how much energy released and how much energy is catched by the house. It's all about energy here. And energy, it's a lot in the forest. And it's very much dependent on the forest state. Like 2 kilograms of wood at 10% humidity, it's about the same as 1 liter of oil and or gasoline. And a green wood at 50% water, it's just a little cup of maybe 20 cubic centimeter. So the state of the fuel and how the weather is defining the state of the fuel, it makes a big difference, but you probably all know that. Just in terms of scales, like tall grass is about half a liter of gasoline. A small island is going to be 30,000 barrels of gasoline. And a forest like Land de Gascogne is 35 to the minimum, 35 million barrels of oil in terms of energy, potential energy. But it's not the only energy that is, not only the energy is interesting, is how much energy is released in an amount of time, so that the rate of spread. And it's very much driven by the way the fuel is made and the surface area to volume ratio. So how much pyrolysis can it do in a short amount of time? And is the residence time, so the energy release, so the power that you will actually feel depend very much on that. And it can scale from wood to 1,000 seconds per of residence time to 15 seconds for grass. So these two parameters, they are essential to actually know what is about to burn, and that's basically the science is all about making stuff to compute that and to have to map it all around the world to be able to simulate a fire. But it's not only that in the energy. There's also the energy of the atmosphere, and we do have phenomenon like pyrocumulonimbus and that you see here, and this is not about fuel. This is about the atmosphere. And so if it was just the wind, we could use it and we don't need to couple it with atmospheric models or see the atmosphere and the interaction between the fire and the atmosphere. But in this case, we got a small pyrocumulus. You will have about 1 million liters of water vapor that is condensating. And this releases about 2 million of megajoules. That's a lot of energy. And when it's a big pyrocumulonimbus, so it goes above almost to the lower stratosphere, it's even more. And this energy compares well with the energy we actually have in the fuel that is actually burning. So we have an equivalent amount of energy in the atmosphere that is in the atmosphere because of the fire, and these two are interacting, and obviously the energy balance is big towards the atmosphere on a specific moment. So we need to take that into account, especially for energetic fires that do have that. So how do we do it? Just because we need that, because when we have mega fire like this campfire that grows very much into a day, Sometimes it's because the wind is pushing it, but very often when it becomes erratic, it's because of cloud making the fire own weather. And it's so one approach is to try to solve everything, like the WFDS or fire tech that they have in US or in Europe. And but with that, we do solve every small energy transfer in every particle of the fuel. And thanks to that, it's possible to compute all the energy balance and whatever is consumed, whatever is released to the atmosphere. And so thanks to that, it's possible to very finely simulate the small scale. But unfortunately, to do that, we need to go to the fuel scale. So every particle that is burning, so basically it's going to be 1 cubic centimeter or maybe in the order of cubic meter. So to make a big fire like this one, it's going to require an enormous computer that is not yet here. So, and also we need the data at this scale. So this is why even in the 80s, they come up with some simplified approach where instead of calculating how each particle of fuel is burning and the energy is released to the other one, we compute directly the fire spread. It is still an energy balance. So it's energy of pyrolysis is the source of energy. And then you got energy sinks, which is the radiation of the ember, the flame, and the amount of evaporation. So, and you have Rothermel model or the Balbi model or the CM5 model for the Canadians. It's all based on this basic equation somehow. And basically, it helps to compute directly the rate of spread of the flame propagation. But it's a 0D formula. That means that you only have the propagation speed. You don't have the fire spread into a landscape. And for that, we need large-scale data. And unfortunately, it's not very accurate. I mean, thanks to Copernicus and the land monitoring service, we have like 10-meter resolution fuel maps, but the fuel is very homogeneous. Like we have just the information that is broadleaf trees and not how much broadleaf trees are there. Or this is maybe 1 yard, but you don't know if it's 1 yard with or without grass. And but this is the only information we have also with the road networks to be able to map a landscape like for the whole Europe and as precisely as we can. And this is all derived from satellite data. So it's updated as frequently, but this is all we have in terms of information about what is actually burning. The code we developed, and most of the codes are basically based on that. So we do have our own code to make the coupling at the fire scale, and everybody can download it. It's open source, so it's a bit like the Farsight approach or the S-Fire in US. So it computes the envelope of the fire, but we need to be because into such fire we need to know as well when the fire stops. We need to be quite high resolution on the way the envelope is moving, because otherwise we will not take into account a fire break, and the fire break actually stops the fire. So it will stop the fire from burning a very large area afterwards. And so we developed this code so to have a very high resolution and still to be fast, so to be able to simulate about 1,000 hectares per second without the atmosphere. And it's actually now the code in use in the French National Service crisis management platforms. So, and you can try it online there if you want with at this address. So basically, with that, we don't have the atmospheric coupling, but we can simulate fire like that. It was in, and then from that derives So it's done on the day of the fire, and from that we compute other variables such as the cost of potential fire without the action of the firefighters, and it gives us insight on when the fire is going to be going to have the cost raise a lot. So we know that using these kind of tools, we can guess as a first guess when the fire starts in a matter of minutes. That this fire, we have about 5 or 6 hours to go and do something until the cost reaches maybe 50 million euros or so on. So this is the kind of way we use these tools to evaluate the time to attack, and if this fire is better to attack than another one. But in order to simulate very large wildfires, we need a bit more research to take into account the atmospheric interactions. So this is why we coupled it with the French model, which is MESO-NH, and made a few PhDs and thesis out of that. And the basic idea is to have the same surface fire spread code that you have. And so it's on the ground like that. It will take the wind from an atmospheric model. And at every atmospheric time step, which is about 0.1 second or 1 second, it will release smoke, latent heat, and sensible heat to the atmosphere. And the atmospheric model will give back the wind that is computed thanks to this heat source. And then we have this feedback loop that is running every second on the fire propagation model with the atmospheric model. So the base ideas of this is the same approach that is used in Warface fire and used in Greece, developed by Theodoros and his team using the ERIS rapid response fire spread forecasting system. But it's not the same code. This was a US code, so this, to our knowledge, the MESO-NH approach is the only European one. And in Australia, they're developing Access Fire, which is about the same kind of ideas, but it is with the derivation of the UK Met Office model. So to do the coupling, we do have actually different resolution into the models. So first here is it's about 10-meter resolution combustion model that we can see on the left. And it's integrated into within a maybe 80-meter resolution grid or 50-meter into the atmospheric model, which is so a lot of this red square here ends up in a big red square there, where all the heat and energy is summed, and then it is run into the atmospheric model at the atmospheric resolution, nested into. So we performed some validation, like maybe 10 years ago with such code, to see that we do actually without cloud interaction, but it's possible to resolve the vertical, the convection using the atmospheric model, the convection within the plume. So we have good matching with vertical velocity, and that was with fire flux experiments. So that, and then we move on to that was 2 years ago. But this case is very nice because it very much shows the ability of this model to simulate the actual pyro convection and the interaction with the clouds and high altitude clouds. So this is a Pedro Grau fire that most of you know very well. I already showed these things in many cases, but it illustrates. So what we see here is it illustrates the whole coupling, this visualization. So what we see here on the surface is a turbulence or in the atmospheric model caused by the presence of the fire. And here we have the smoke in the plume. So so we have the water vapor in the plume, and what we can see from the here is the front coming, like it was a dry thunderstorm day in the area, and the dry thunderstorm is making a lot of change in the local atmosphere that is influencing the fire. First, you have this ice cloud in light blue, and then you have the wind, the downburst. So this is all the cold air that is coming down from the ice clouds and smashing into the ground, that as we can see here, and creating a lot of wind and turbulence. But at the same time, the atmosphere is very unstable. So when you do have that, you do expect some formation of cumulus clouds a bit everywhere. And because here the heat source is an instability on the ground, you do have the formation of a cloud above the wildfire, and this cloud is generating a strong uplift that is creating a lot of wind that wouldn't be there if there was a fire. And in a matter of an hour, it accelerates the ground wind to 5 times and creates some wind effect that we could not be able to forecast if we didn't have the fire and atmospheric coupling. So it's a work we did with University of Évora and Katia Campos that is listening here. Just to illustrate such coupled effect, in here we do have the same fire, but we simulate it in red. That is the area with coupling, and here we didn't inject any heat from the fire. So it's a fire to atmosphere to fire coupling, and in top right we don't inject heat from the fire. So it's basically a fake cold fire. And at the bottom, you could see the observed fire area and the fire growth. That is, we came from the official report. And in red, it's with coupling, and it's black, it's with coupling, but 100 seconds after. So it's a historical. It's like the back of the fire and the front of the fire. So basically, you do expect to have some interaction, but some pyroconvection here is not existing if the fire is cold. It's the same atmosphere and the same simulation. The only difference is that we release heat from the fire. And at some point, the cold fire is even able to overpass the coupled fire. But when we do have pyroconvection like here, and the pyroconvection is there because of the fire, then the acceleration on the ground is making the fire line having the same acceleration at the same time as what was observed during the day. To do some validation of some of such models, we also need to have data. So first of the data is a satellite, and this is a collaboration we had with the Bureau of Meteorology and the Ballarat fire of February this year. And another very important data is to perform validation is the radar. So here is a Melbourne radar, and what we see here is the propagation of the coupled propagation, and we also have a time-lapse camera from the bushfire research in Victoria. So what we can see in here is actual. So in white, what you see is the condensed water. So it does pyroconvection. And when it does that, the plume is picking up winds from the higher atmosphere that is moving the whole plume towards the east. And doing that, it moves also the wind on the ground. So it makes the fire propagate in another direction just because the top of the plume has picked up another wind from the shear of higher altitude. So, and using the radar, it's nice. The radar eventually went off because of overheating, but what we can see is that the plume is about the same shape, and here we can see about the same height as well as the actual plume. So we know that we had overshooting using radar data. We also use this kind of computation to perform what-if scenarios for to do fuel management plans. So we make fire as accurate fire as possible, and try to see if villages may be protected or not, given some fuel treatment that we could do on the ground. And because it's even at very local scale, you can see here condensation, it can have an effect on how the fire accelerates, and if you have topographical configuration that it will occur. So we take archive weather data and do that. And lastly, in such models, it's also, and it's ongoing work with the University of Melbourne with PhDs there. It's the only way to actually know what will be the vertical convection that will transport long-range spotting. So that the next level is to define area of high spotting frequency. So how to deliver such results? There's a big problem because there's nice videos, but we do have too much data. It's about 200 gigabytes every time. So I know that ISIS made some work on how to deliver such data, and we do have this kind of same problem. So basically, when we use in the frame of the FireCast project, we use such simulation in a way that we do 24-hour forecast when we have information from a place where we have interaction. So basically, the Canarias, Gascogne, and Portugal, and try to see how we can use them and define some standard plots that could be used after with. So every firefighter on the field will have the same reading, know the colors, know what it's all about. So the basic idea is to run it every 12 hours, make an update, and we have the first forecast 2 or 3 hours after alert. So it's only for potentially large fires that we know that they're gonna make a big fire. So here are the plots. Here is about so this is a standard plot for wind gust, wind field, and updraft. So it's going to be for every fire that's hourly plot of what's happening into the atmosphere. So we have strong updraft, turbulence, and wind field, and fire propagation. Second standard plot is about ground smoke concentration. This is in the Canarias Islands. So there, it makes some interest to know where are the areas of strong, where it will be hard to breathe, and where the plane could maybe not be of assistance. And the last plot, so is the fire plume. So it's on a larger scale, and you have the altitude of the top of the plume and the altitude of the bottom of the plume. So you know if you have smoke on the ground on a bigger domain, and you know if the fire is actually overshooting. So if it's the altitude of the plume, it goes over 1,000 meters, that means that it's probably becoming a cumulus cloud or even higher. So you do expect some change in behavior. As a perspective, we are also interested into looking some smoke plume infrastructure and providing radio sounding typical plots, but this proved to be quite hard to be of actual interest into the ground. Basically, I also act as a volunteer firefighter, so I also try this kind of thing every summer. When with Forest Service, I provide some weekly weather notes for the fighting service in Corsica, and using mostly ensemble forecasts. And also in case of emergency, I do fire weather analysis just during the service. What I want now, if you want to try with me, is to if you can go, but there's other ways as well to interact, and this amount of information is very hard to pass to the field. So So what we can do is to go to this address together to try out new ways of
Jean-Baptiste,
yes.
can you please share the link on the chat so that everybody can actually access directly?
That's the thing.
Yeah,
So
that would be awesome. Okay, this one, yeah. Thanks.
So if you want to try that, that's another different way to interact and to see weather forecast. Because it's so much data when we do such simulations that we need to find a different way to interact with the people. So I can see people here are connecting. So using the mouse, if you click in the window, then your mouse gonna control what you see. And using the arrows on your keyboard, you can move around. Then, using spacebar, if you aim at, here is the network, the electrical network of Corsica. So you can try to annihilate it just to see what will be the eventual cost of something coming there. If you press M, you can change mode, and you can put you can go to smoke mode, the M, where you can inject smoke and see where it goes. Or you can even change and trigger a fire somewhere. And the fire will launch, this will launch a simulation of fire. So what you see here basically is it is within a forecast of 48 hours of the 16th of April 2024. So this is a way maybe you could do tactical situations analysis into for collaborating things even at European level. So it is a kind of a scenario that you will that can be shared and with many information on the ground. So thanks a lot, and I leave you play and with the programs. I had 30 minutes, so I hope, Giorgio, that I took the time.
Yeah, you did great. Actually, you ended earlier. Thank you very much, Jean-Baptiste. This is really great. And thanks for providing this tool to play around for the rest of the day, I would say, for most participants. So I think now we can open the floor to people to ask questions. There are already some questions on the chat. I have also received some questions while the two talks were taking place. Shall we start from the chat? Let me go and have a look. Or basically, I could start from the one that people submitted during registration, since we got some extra. One question basically for both of you, I would say, since you try to do things on both sides, combining research tools into operations, there's a question about how can academic research better meet the needs of practitioners in the field? I think you already mentioned some stuff during your presentations, but if you want to add something on that, maybe Jean-Baptiste, you could start since you're more from the research perspective, but you also are involved in operations. So, and then Hector, you can take the lead and address this if you want to add something, of course.
But I think Hector showed what he used, like EFIS and WAS and the Copernicus Emergency Service. Eventually, he probably is flooded with new indices and new approaches with like even practitioners. So and new stuff like even idea is that it's probably down to people like Hector to find if something is of interest for him. He will probably change the use and spread the word to all the other practitioners in Europe and so on. And I know in France, like the use of the fire propagation tool is the most biggest use is not during the fire, but it's after the fire to know how much fire saved, and to make nice images to show to the city councillor, just to share, oh, you need to evacuate your village. Look how it's gonna look the fire line in 2 days. So this is not for taking responsibility. So our goal is to speak with Hector to see what he will like to have. And I guess he is very much afraid of this mega fire events and the one with strong interaction with the atmosphere, the one that creates their own weather. So, but he will not process 200 gigabytes of data. So what kind of plots he wants and all these things. So it's and NERO is important for that. I mean, to put in contact practitioners and what so they know that we can do it. And then if he's interested, they know that I'm open to create the plots and the way to deliver the stuff. Speak too much.
Yeah. To complement.
Yeah.
I agree with Jean-Baptiste, and one thing that we need tools to understand what's going on, but tools that have to be easier for the practitioners. I mean, we are not the scientific. We don't need all this. We don't have the same background, and but we need to be updated all the time because science is evolving all the time. And I would like to have a platform where I can have to know what are you doing in all the investigation, everything that is done regarding wildfire, so I can see what's going on and try to understand everything. But because there are so many projects and so many investigations, but I think that I don't know if you know what's going on worldwide regarding wildfires. It's very difficult.
Yeah, thank you both. I think, the thing also that is the aim of NERO is like to listen to the practitioners' needs and come back and connect connections and operations to products and tools that can be easily digested into operations. I think this is a very big challenge. I mean, worldwide, but not only in Europe, but it's something that we try to do here. One more question, or a couple of questions. It's probably already addressed also during some of the talks. If you want to add something, is how can we enhance the effectiveness of international cooperation mechanisms in wildfire response? And what are the biggest challenges that ERCC faces in operational processes, and what strategies are being planned to overcome these challenges in the future? I think both probably directed to Hector.
Yes.
Yeah.
The first one to enhance cooperation.
The effectiveness of international cooperation.
Yeah, international cooperation. I need that we still need more operational tools and develop tools that are there, because now I show you this tool-based synergies that we are trying to put in place, but there are countries that are already using it. So it should be easier if all the countries can use this type of tool. So it will enhance this effectiveness. Mm-hmm. And the second question was, can you repeat it?
It was about the biggest challenges that ERCC faces in operational processes and what strategies are being planned to overcome this kind of challenges in the future.
Well, they at the end of the day, the response of the ERCC depends of the member states. So you cannot be able to give a response to a wildfire if there is not this collaboration. It's up to the member state, but what is trying to do the mechanism is to reinforce reinforce this rescue layer, so that you can have not the control, but you can have something to say in this response. But as you can see, it's not only about response. I fully agree that the most important is prevention, and there are so many projects that are focused on preventions and investigation that I think this is the way we need to take.
Okay, thank you very much. Finding another couple of questions from the chat from Fabio Silva. I think one directed to Hector and one directed to Jean-Baptiste. I will start with one to Hector. What kind of capacities can be improved in the mechanism when in the ERCC or designed directly in the field during operations?
Okay.
So what kind of capacities can be improved? Yeah.
For me, I would like to have one capacity in the ERCC that would be to have a team of 5 behavior analysts to have but at a strategical level during the summer, but the whole year, but also teams of fire analysts working on at operational level when we have the deployments of the mechanisms, so that they can complement, they can support the teams that are deployed, but also to the host nation or the countries that have the fire, because there are countries that have developed this capacity as national capacities, but not most of them don't have this capacity. And we are seeing every day at some point there are many requests that you can see that the request because when a country make a request, usually they need to say, okay, I request this and this means for 3 days, for 5 days, for 2 weeks. So you need to do an assessment, you need to know what's happening, you need to know to forecast what's coming, and not all the countries have this capacity. And I think it should be great to develop this type of capacities and spread in all the countries.
To supplement this question, now that you addressed some of these parts, can I supplement this question with something more about the capacity that you have in terms of fire meteorology? Even from my personal experience, I've seen that in decision-making cells in Europe, in different countries, I don't want to name countries, but there is a big lack of fire meteorology information and fire-specific related information regarding weather conditions. And most stuff that even myself as a meteorologist, I'm familiar, but I was expecting that this kind of capacity that is very necessary for also medium range perspective, longer range perspective, but also in the short term, but also real-time analysis, it's very much needed. Does the ERCC has this kind of capacity, or it's included in the needs that you mentioned earlier?
Yeah, it should be included in this needs. During this, when we have this wildfire support team, some of the scientific that are coming are meteorologists, but it depends on the background they have. Sometimes it's not the same meteorologist that doesn't know anything about wildfires. So it's not easy to find people with this background. And for me, it would be great to have maybe you, who knows?
No, okay. I didn't mention
this is I totally agree with you, Georgios. And I mean, it's in the service in Corsica. It's what I'm doing, and it's all, as well for scientists. It's so interesting because then you can analyze the clouds and even during the formation of firefighter so I give lectures sometimes to them so they can learn how to read the sky. I mean, to know when you have hole in fun clouds, that's very important. To know that if you have a little white cloud over, there are so many things and to be used on the field, and to know when So, and even the tools that the online tool that I play with, it's very much it's very helpful to understand that the terrain would very much influence the way the wind goes behind the mountains and so on in very mountainous area like you have in Greece. And so information is a decision. It's all about the amount of information you can handle, and it's very important.
Yeah. Amount of information. I would also second and say that it's also the interpretation of all this huge amount of data, especially if you want to talk about the far atmosphere coupling situations when everything is way more complicated. So the second question from Fabio Silva is directly to Jean-Baptiste. So could this work be integrated into a European platform and accessible to all users with the comment, of course, in a user-friendly mode?
The fire simulation things without the coupling, that's
or the coupling stuff, I would say.
the fire. If I can share like this thing like that, like I just simulated a fire in the Atticus. Everyone can go there and do a simulation and end up with a fire propagation like that. It works in Atticus, in Rhodes, in parts of France, and if people want to, so that's easy. Then it's up to the Hector to say to the FIS that he wants such system, but it's already helpful. The coupled one is up to a weather service center to do it, like you do, NOAA. Like and you did develop one with the Warface Fire. I don't like American code. I like my American colleagues, but I would rather do it in ECMWF. I know they're preparing something with the people there in charge of FIS, but and then to the local weather service, Meteo France and Meteo Greece or National Observatory of Athens. So it's not up to us. We are ready.
Yeah. Okay, that's great, and indeed, it would be great if this kind of tools could be integrated and this kind of big platforms that everybody is using. So let's wait
Hector
for some.
has to ask for it. So.
Yeah. Hector?
Yeah.
Would you love to have such a tool?
Yeah, of course. Of course, I would like.
So yeah, I think it's a matter of decision, I would say, to some point, and also the awareness of people from the ECMWF in regarding this kind of information and how much is needed from people from the operation side to kind of develop this kind of procedures. Moving to the next question from Domingos Vegas. Great talk, Jean-Baptiste. Can you comment on the role of atmospheric stability in the physical process? Or Domingos, if you want to comment something more, you're also here. I can see you, so feel free to.
Georgios, can you answer this one? You will answer it better than me.
Yeah, I mean, yeah, the question. Yeah, I mean, for the cases that you illustrated, probably, Domingos, are you referring to the Petroglyph fire, probably, or? Yeah, I don't know.
So it's all about the energy, the potential energy you have in the atmosphere. So if you have plenty of potential energy in the atmosphere, and you do actually have plenty of potential energy on the ground, then both will interact. It's a thermodynamical system. So if you have low potential energy, and you have like wind is kinetic energy. It's a lot of mass of air that is moving very fast. So it's an enormous amount of energy, tons and tons of stuff moving at hundreds of kilometers or tens of kilometers an hour, and it interacts with combustion. And the other one is latent heat. But what I try to show at the beginning, it's the amount of energy released by condensation is approximately the same as the one you have on the ground. So it's not it indeed interacts a lot just because it's energy balance and stability is actually that the amount of energy that would be released by the atmosphere. If it's unstable, it's able to release a lot in a quick amount of time. It's very stable. It will not release it. It will just keep it and move it.
Yeah.
Am I okay, Georgios?
Yeah. I'm satisfied. Don't worry. So the next question is from Juan Camano on paraconvection is more closely linked to the quantity and availability of forest fuels or the configuration and characteristics of the atmosphere. I think this is also directed to Jean-Baptiste.
Yeah. So if you have a lot of big energy in the atmosphere that is just about to be released, like some water in a pan that's gonna boil, but it's just about to boil, then at some point you need an instability to make it boil. So if you have a lot of energy, but it's not that unstable, you need a big instability. So if it's a big fire, it could trigger convection in a relatively unstable atmosphere. But in a very unstable atmosphere, even a small fire could do. So obviously it's linked to the energy you have on the ground, but even non-so energetic fire could create their own weather if the atmosphere is very unstable. So it's not definite answer. It just you have energy on the ground, energy in the atmosphere, and it's a balance.
Yeah, that's great. Thank you. And then we have questions from Nikos Kamakiotis. A couple of questions for Hector. Sorry. So is there a post-incident evaluation of ERCC missions? So there are many questions actually. So is there a post-incident evaluation of ERCC missions? The main concern as for wildfires is the time frame. You can also read the question because it's pretty long, Hector, from the chat, right?
Okay.
Yeah. So there had been several cases in Greece and Cyprus that aerial means arrived a lot after the completion of the violent stage of the fire. So is there analysis and feedback provided to the states deploying the mechanism towards their improvement?
Okay, yeah. Regarding this, the deployment, we need to be clear about that. The mechanism is not the first responder. The mechanism was created when a country is overwhelmed. So when you have a fire that burns in the main hours at the beginning, or in 6, 7, 8 hours, 1,000, 2,000 hectares, you cannot expect to have the mechanisms assets there because it takes time to deploy them. For instance, this year, I think that the faster deployment was were planes from Greece that were deployed to Albania, but they were based in Corfu, so it was like a 30, 40 minutes flight, so it was very fast. But usually the deployment takes longer than that. It's more than, it takes a lot of time. So sometimes the planes or the assets arrive next day or the GFF. So we need to be clear. It's not the mechanism is not it's not the national response. So
it's not for responder, it's for support and
it's for support. So
especially for big events and multi-day events, it makes sense.
That's it. So when you have a fire that lasts 1 week, or Alessandropolis last year, of course, the support arrives when it's needed. Not at the beginning of the wildfire. And then, yes, we evaluate after the missions, and we have lesson learned. This year will be in December in Madrid with all the countries. And in this lesson learned, we put on the table, we talk about all the deployments and what we could do or what we should do to improve for the future. So yes, we try to do it. But at the end, each country needs to take care of their own capacities, and the first response has to be national.
Yeah, that's great. Thank you very much, Hector. Then we have a question from Martin, a question for Jean-Baptiste on the planning tool for vegetation management to protect villages. Are you studying the effect of fuel breaks? And if yes, what data set are you using to simulate the effect of such fuel breaks?
So basically, I have the for high resolution, very high resolution stuff. We may use LiDAR data that is provided by France for the whole country. But other than that, we use the standard map I've just showed, so the 10-meter resolution, but then we use GIS tools. So we remove vegetation someplace and we rerun the simulation with and without the treatment, and then we make the maps, and you have energy release at some points, and we look at the energy. Not only released but catched by the house on the village, and then it makes scenarios. You see like that. Okay. This kind of thing.
That's great. Thank you. Then we have a question from Jesus Morcillo Zulia. Question to Hector. I wonder if the sharing cooperation mechanisms are being implemented in the most optimal way. Have you considered to what extent could we engage more professionals and resources to it? Because there is a good number of interested professionals who are excluded because their organizations do not engage, I guess, to the system.
Yeah. The mechanism is a system that engage civil protection authorities, the national authorities in each country. So it depends it's up to them who participates, and it depends. For instance, I come from the Forest Service, but it's not I'm here because there's a good cooperation, because our civil protection national authority and the Minister of Ecological Transition. So it depends of each country, but the mechanism was great like that, and I'm aware that there are professionals that are not in the system because of that, but it depends on the country. So it's something that national authorities should try to solve at some point.
Okay, that's great. I think Jean-Baptiste deal with a question from Nikos on the reconstruction of wildfires. You already addressed it on the chat, right, Jean-Baptiste?
Yes.
Okay. Now I see it. Yeah.
It's important data to validate the model, and NERO is doing a lot for that.
Yeah.
Well.
Yeah, I think high resolution mapping, it's very important for this kind of case, especially the most impactful ones. So I don't see any further questions on the chat, but I think some people might want to ask them directly. So feel free to take the floor and ask to the two speakers that we had today. Otherwise, I have a question. Yeah, please, Mario. Yeah, Miguel.
Hi, everyone.
Yeah.
I have a question probably for Héctor. We keep talking about this tight collaboration that I think everyone wants, right, between practitioners and researchers. And there is a topic I've heard discussions about as well, and that also people are discussing in the US, and is the possibility of researchers accompanying practitioners during your daily work to better learn all those needs and see the transfer possibilities of technology and what needs to be developed, what's useful, what's not. It's because it's really hard for scientists working in silos to know what actually is useful, right? And a lot of times we end up doing things that are not useful. So I was wondering, from the European mechanism or any other European agency, like how do you see that possibility of finding a mechanism for researchers to deploy with you or do short stays with you during the fire season, maybe during prevention work as well, or analysis of past incidents? I don't know, anything that could help to promote that collaboration.
Yeah, I fully agree that it's necessary because it's the best way to understand each other is working on a daily basis together. And we have during the summer some scientific from this consortium, Aristotle in the ERCC, and it's useful for us, but also for them. But I don't see the way to do it like in a regular basis. You know, maybe it will be easier at the national level or regional level. But yes, it will be great, and I think that is one step that we should take in the future.
Yeah. May I second this question a bit more before I give the floor to Domingos? Like, I fully agree with Miguel about that. That maybe the whole European agencies could be a bit more open for this kind of discussions, to break this kind of silos, to break this kind of closed doors, in a sense that it's better if you're able to connect with more people and listen to the actual needs in the upper levels of the mechanism, down to the national level, of course, because you can see it in the national level. You might have some problems in terms that you might be excluded from the national system in a sense. You might not be included in the processes, but you could contribute. And probably this is why, I guess, in a European level, you probably don't have access to this kind of meetings, for example, or let's say chances to discuss and talk about these things. So maybe some kind of and more open event could help to this kind of situation. Yeah, please, Jean-Baptiste.
Comment just a little bit.
Yes.
I'm a volunteer firefighter, so I'm actually every day on the ground with, not every day, but on alert, and I make this weekly bulletin as a fire weather analyst. So so as that, I cannot be, I'm at the regional level. So the regional level is actually the people that are working on the field. So I cannot be included into the rescued but maybe I could be included into that, but you're totally right. It's not the decision level. It's not European decision level. But maybe Aristotle is the way to go. The one you have there. You already have a system somehow. We just don't know how to enter it. Aristotle.
Yeah. Domingos, please.
Okay, first of all, I would like to congratulate NERO for this event and both speakers. I would like also to follow on this discussion that was just started with Héctor about the participation of the scientific community and also the scientific results in your work. What you presented is great, and it is a great service that you are providing not only Europe but the world. And of course, I comment on the field of wildfires. I think it's very important that we researchers and you be in touch. As many of us here are in these Green Deal projects, we are producing results and products, and we are trying to put them together and to make them known and available to the European services. Actually, this week we had a meeting of the coordinators of different projects, and we are working on how to showcase our results to Europe. And we are actually preparing some work and some documents and an event that will take place next year in May in Brussels to present some of these results. I think it's very important that we work together, not in silos, each one in his project or his country, but we try to work together and push our results together. For example, I see that the full maps that are being used by some projects do not take into account that, for example, in the project Fire Risk, in which I'm working, we developed and proposed a full map. And this is just an example of things that can be shared and used together. If you allow me, I would like also to make another question to Jean-Baptiste. I enjoyed very much his talk, and I made a question. But my the main question is, I'm the feeling that the great part of energy comes from the ground, from the combustion. And this happens at every scale. Only in, let's say, larger scales, the processes of condensation and the interaction with the atmosphere begin to exchange energy, as I said, that may be relevant to interact with the fire. But this interaction from the processes that are happening 8, 9, 10 kilometers above the ground, how can they be felt by the fire that is at zero height? This is my question. Thank you.
Okay. Just, it's all about when you end up with you start to have interaction when you have a white cloud above the if you have a white cloud into your plume, then it is an interaction. You always have interaction with the wind, but that's going to be interaction because of condensation of air. Then you can imagine that you will have when you have this white cloud, that means that there is updraft under that is bringing air there. So there's a vertical wind speed component. And in a pyrocumulonimbus, the vertical component of the wind speed is about 100 kilometers an hour. But this wind, where does it come from? It comes from the ground. So it's like a big cloud that is sucking up all the air around and push it somewhere else. And the thing immediately behind it, or behind the plume, is the actual ground. And it's a lot of air. So it's like having a big ventilator, maybe 1,000 meters above the fire that is taking all this air and pushing it somewhere else. So it is very strong currents, and so the wind is just it modifies the local wind, just like you would have the breeze every day. If you the breeze that is going up the valley, it's the same phenomenon somehow. Just so the instability is not the mountain, it's the fire, but it's basically somehow the same if you have a breeze with a cloud. So it is so much air in the vertical updraft that is actually moving the thing on the ground. I don't know if I'm okay, Georgios. You can comment on that. You're the phenomenologist. Georgios is a forecaster.
Yeah, no, I fully agree. And also something important could be also be the air and the moisture above this plume, and how basically the whole cloud forms and how could be sustained for longer if it's moisture. There's moisture up there or not. So yeah, so many things to consider. Yeah. Anyway, any other question? Because I don't see any other questions on the chat, probably, or there's one more from Miguel. It's not a question, it's a comment, right, Miguel? Yeah,
that was just a comment trying to put together the idea that I heard.
It's good because the chat will be living forever, so we will have this documented, so don't worry. This is great, thank you. Any other comments from the audience? Because we're approximately near the end of this webinar. I don't see any.
Just to say something.
Yeah.
Like Francesca, the group of ECMWF and Francesca Di Giuseppe is one of the key persons, because basically it's the European system for forecasting. So she Héctor, scientific person she's supposed to related is probably her. Voilà. So just to know. And they are developing good stuff as well, ECMWF.
Yeah. As far as I know, they are also developing stuff right now. As far as I know, I've seen some papers, and they're preparing some projects that could be helpful for.
Yeah, and they've got the scale, and they've got the supercomputer to do that. So
yeah. That's why the question also from Fabio that we discussed earlier, that, for example, this kind of tools that require a lot of computational capabilities require a strong computer to do all this kind of stuff, especially in real time. one, you want to have also a probabilistic perspective in your situation, or if you have multiple cases happening in a European scale at the same time. So it's pretty hard from the computational perspective, as far as we know, also from the weather forecasting perspective. So it's a challenge, but it's a decision that could be made at some point, and it would be very beneficial for ERCC or even for the national mechanisms that collaborate with the European civil protection mechanisms. So once again, I would like to thank both of the speakers for the great presentations and, of course, the nice discussion that I believe we had. If you have more questions, you can directly find these two people and ask them directly, or if you cannot find them, just drop us an email and we will bring you in contact. If you want to have more details, more questions. Once again, thanks a lot for joining today, and we will see you to the next NERO Network Café. Have a good day.
Thank you very much.
Bye. Bye.
Thank you, guys. Thank you.
Thank you. Bye.
Thank you very much. Goodbye. Goodbye. Efaristo.
Thank you. Bye.
You're welcome.
Thank you.
Thank you.